Very good afternoon, my dear students. Today, in the introduction to computer system, some section of the memories and working with the memories that I am going to discuss today. Okay, memory system and how the memory system will going to work. So, memory. What do you mean by the memory? Computer memory. As the name suggested, that this particular computer memory is just like a human brain. So as we have a human brain, as we store the data and instructions, these the particular structures that we can store. We can store the data and instruction in a computer memory. Okay, so all those data and instructions what are there that are stored in this particular section, that we will going to work on it. Okay, so computer memory is a storage space. That means there is a particular storage space that we will going to find. So in this particular storage space of computer, what we can do, we can store the data and we can work with the data. That means where we can find the data is been processed and the instructions that we require for the processing are stored. That means what the instruction required, that the instruction required are stored, isn't it? So this is the section where we find that collection of cells with an each unique physical address. That means each of the cell, this is one cell. See here, which I am circling, this is one cell. Similarly, up to this much, there are the how many cells? 1, 2, 3, 4, 5, 6, 7, and 8 cells are there. So all those 8 cells, what we find that they has a different address of it. Okay, unique address they do have. So most of the computer, what we can see that our computer data are being stored in a what system? In a machine language system. Machine language system is binary code. Binary code is a combination of zeros and ones. So when we are including the zeros and ones, that particular zeros and ones, what we find that they will combine a bit and byte, isn't it? So these the addresses what it will going to contain. The cell at the address of 11111110 contains this. So this is what this is the particular address bit of this particular data. That means bit position. What we find that each of these bit position, this is the addresses what it has got. This is the address of each of the cell. This is what I am circling at this moment. So and this is the values that are being stored. So what we see is that memory size, if the computer has an 64K watts, okay, then the memory will be what? 64 into 1024. That means 65536. Okay, 65536. This is the memory what the memory will have, and this is the memory location. Memory location will then start from 0 to 65535, isn't it? So this is how we can see, this is how we can find it, that we will going to have a different patterns of what? Different patterns of the memory system. Clear? So this is how the memory is being stored and memory is work. Now memory unit, the memory what we are storing, memory has got a different unit of it, isn't it? So data that we are filling to it, the data, the files, the programs, whatever it is, whatever we require, each and everything has got a different unit. Like bit, first unit is a bit. What is a bit? Bit is a binary digit, ones and zeros. Then nibble, 4 bit make one nibble. Then byte or octet is 8 bit. Then kilobyte, 1024 bytes. Megabyte, 1024 kilobyte. Gigabyte, 1024 megabyte. Terabyte, 1024 gigabyte. Petabyte, 1024 terabyte. Exabyte, 1024 petabyte. Zettabyte, 1024 what? Exabyte. And yottabyte means 1024 zettabyte. So see, if a person possesses this one yottabyte, that means you can imagine how big the memory is. A huge memory which cannot be finished by that particular person in the lifetime, isn't it? So we are talking about now how much TB, 1 TB, 2 TB. So 1 TB, 2 TB we are talking about. But if you have a 1024 TB, isn't it? So that particular, that means if we have a petabyte, that is a huge than this one. So this is what we can find, this is what we can see, that each of this section what we have, each of this part what we have, this each of these sections are being stored and are being utilized. So this is what their data specifications and their abbreviations. That means byte means b, kilobyte means kb, okay, megabyte means mb, gigabyte means GB, terabyte means TB, petabyte means PB, exabyte means XB, EB, and zettabyte means ZB, yottabyte means YB. So this is the thing what we find. This is the thing what we can see, that we do have this pattern of a memory section. So see here, memory, as we are discussing about the memory, memory is what? Memory are of basically three types. One is a cache memory, isn't it? One is a primary or main memory and another is a secondary memory. So cache memory, what is the cache memory? You see here, the cache memory is there, isn't it? So this particular cache memory, what you find it, it is very high speed semiconductor memory. Okay, so high speed semiconductor memory that we have, the high speed semiconductor memory will going to do the work, that means can speed up your what? CPU. This high speed semiconductor memory can speed up what? Your CPU. Now when this high speed memory conduct will going to conduct the CPU, what will going to find it, there are the different type of effects. The buffer between the buffer, that means see here, this is the CPU, this is the primary memory. Okay, so this is the buffer and this is the primary memory. Based on this particular thing, what we can find it, that they are being stored, isn't it? So each of this particular section, each of this particular part, what we are having, so we are having this particular sections in which we can what? Use it, we can make it, isn't it? So each the making of this particular section is the making of this particular memory sections, what we find it, that those the part of data program are most frequently used by whom? Most frequently used by this CPU, that means the central processing unit. Okay, so central processing unit use it and use this particular memory for storing the data. There are the different pattern of data we can find. There are the different types of data that we can find. So each pattern of data what we have, each types of data what we have, the data are being stored. So storing place is where? Storing place is this cache memory. In the cache memory, we can find it, the data will going to store. So primary memory, what we find it, in this particular primary memory, we do have a what? Storage. But before of that, the cache memory take the data and store the data. Now type of the memory, what are the advantage we can find? The advantage of cache memory is that cache memory is very fast, isn't it? Cache memory work very fast than the main memory. The main memory what we have, the main memory what we find, that each and every main memory there is a particular section, and this particular section what we find, we have a cache memory, and cache memory can store the data in with a very fast way. Next what we can find it, that consume a less time. Cache memory what we find, the cache memory consume the very less time comparing to that particular memory section, any other memory section. Okay, next what we can see, that in this particular section, that when we are talking about the cache memory, we find it the storage of the program that can execute with a very short period of time, isn't it? So this particular short period of time means what? A very small time it can do the work. Next what we can say, storage of the data is what? For temporary use. Temporary use the data are being utilized. Okay, so those the temporary use what we find, that those the temporary part what we find, that each of this data will going to store temporarily. So this is the thing, this is the part what we can say, this is the part what we can find. The cache memory do have, those are the things what cache memory can have. That means cache memory has a limited what? Limited capacity. Clear? Cache memory do have the limited capacity, and it is very what? Expensive. It is very expensive, the cache memory is. As the cache memory is very expensive, we can find it that each and every cache memory will going to have what? Going to have their work in a different form and in a different way. Okay, so these the different formations and the different way the cache memory is there. This the particular cache memory will going to introduced by what? Introduced by the different types of storage function. Okay, it is introduced for different type of storage function. Now, a type of a memory. After the cache memory, what we can find there is a primary memory. Primary memory means main memory. Main memory where we hold the data, where we find the data can be stored, isn't it? So as we store the data, as we find that particular data can be stored, each and every data what are there, each and every instructions what are there, they are what? Currently working. Where they are working? In the particular CPU. So those the data what is working, they has a limited capacity of our data is lost when the power is switched off. As soon as you switch off the power, what will happen? What the data is stored, all the data will be wiped out. So it is a semiconductor device is there. So this the memory what we find, the memory has and first is as registered, isn't it? So as it first as register, we see it the data and instructions that is required to be processed. What we find, it resides in the main memory. That means it keep in the main memory. Now this main memory is divided into two parts. One is RAM, one is ROM. RAM and ROM. This is a ROM and this is a RAM. So how does they work? What are they? RAM and ROM. Let us compare them. Let us find out how the RAM and ROM is working. RAM full form you all know, ROM full form also you all know. RAM means random access memory and ROM means read-only memory. Now, the basic thing is it's write the memory. Okay, read-write memory. It is only reading memory. Unit, the storage data is currently possessed required for booting computer. Next word, this particular thing is volatile memory. This is a non-volatile memory. Okay, then what we can find it that in this particular section we have a standard. Standard for what? Standard for this random access memory and read-only memory. So modifications what we require. The modifications is there. The data in a RAM can be modified, isn't it? So data in a RAM can be modified, but here you cannot modify them. Capacity of what? 64 to 8 GB and here smaller than the RAM, isn't it? The cost is what? RAM is costlier, very expensive, but it is cheaper than RAM. So what is the cost of a RAM is more than that, it is cheaper than that. What is the type? Type we find RAM is what? There is a dynamic RAM and static RAM. Static RAM and dynamic RAM. But what do you find? Then EPROM, that means electrical programmable ROM, read-only memory, and EEPROM, electrical erasable programmable read-only memory. Okay, so those are the two things what we find. Those are the two part what we find, that each of these particular sections what we have a different way to conduct, a different way to part for this particular storage. Different storage has a different unit, and those different unit what we find, they are being stored in a different way. Now data transfer rate, what we find, the data transfer rates are there. The data transfer rates of in this particular section is that there are the different types of working form, there are the different patterns of working form. So those the working form what we have, what we find that in each and every working form what it has or what it will going to find it, that are what? A physical weight. That means we have a physical weight. That physical weight is what it is said? It is said as a bus, isn't it? So using the bus what we can do? We can send the data. So bus is a data transfer between a USB, okay, port and the hard disk. Between the hard disk and the main memory, the data are transferred. Now bus has a three type. What are they? One is a data bus to transfer the data between the different components. One is an address bus. That means it will help to transfer the address from CPU and to main memory. Okay, so these are the data what we find they are going to transfer, and those the ways the thing will be implemented. Clear? So these are the implementation what we find. These are the implementation what we are imposing. That each and every implementation what we have, we want to specify them. We want to make the particular thing, isn't it? So here you can see that how the different buses are there. And another what I didn't say it in the previous one, that is a control bus. Control bus is to do the communication of the signal from the different computers, isn't it? So different computers are there, different sections are there of the computer. So each of these three sections, they are connected, they are being transferred. See here, the total system bus. This is the data bus, this is the address bus, this is the control bus. Now you can see here CPU, memory, input, output. From all this section, there is a multi-way connection to them. Okay, so multi-way connection means from any section directly to another section, the data can come. From any section that can be instructed. For any section, we can do the read write. So all this work can be conducted in this particular section. So where we have the hardware components are there. So thank you, students. This is the end of today's session. I am ending up my session here. Thank you all.